Yeah, we at this time we have an audience question. So this one is from Alan. Thank you, Alan. Is the forecast probable range tighter or more accurate if all defined slices of work is roughly the same size?
Ooh,
Yeah, that's a good question.
That's a great question.
The reality is that it doesn't matter if they're all the same size.
That's right.
What matters is that the way that you're slicing things in the future are similar to the way that you slice things in the past. So, for example, if your team is trying an experiment where every card is broken out into 10 different cards, well, okay, your forecast is not going to be useful anymore, right? But if your team is working in the same way in the future as they've been working in the past, so they're likely to slice a few things big, a few things small, a few things somewhere in the middle, then the forecast just works because it's based on that historical data.
Yeah, it's consistency, not size. If you have always one really big thing, 3 medium-sized things, and 12 trivial tasks, if it's always like that, more or less, it's always going to come out right.
Yeah, it's the data sample. The more samples that you have, the better or more accurate, using that word that you used earlier, the forecast works. So you need more data sets.
My experience with, obviously, I think all of y'all would agree, working on big things is less predictable than working on small things. So,
Absolutely.
we often coach our teams to slice the work and slice it into small pieces. So, if you begin doing that, let's say, as Kevin said, you start an experiment, we'll say as a team, we're no longer going to work on really large pieces of work. We're going to intentionally slice that into smaller pieces. It's going to change the dynamic of your throughput because you'll be completing more things more quickly. But the nice thing about Monte Carlo is that you can decide what range of throughput will be the input for this forecast model. So if you have a big change in the team, maybe you add 5 people to the team, or maybe 3 people leave, or whatever. Or if you change something dramatic about the way you are managing the work, you might want to make note of what date that happened on, and you can begin to carve out the data that's most meaningful for this new way of forecasting the future.
And this is both, but also kind of important. And I imagine Kevin has something to say about this. We're shooting for accuracy, not precision, right? And so, it's probabilistic. So it'll say it's most likely, about maybe with why it's 85%, it's 85% likely that it'll land roughly on this date. Mm-hmm. So it's not trying to say at 4 o'clock on a Wednesday. That would be precision. It's about accuracy. So we're right plus or minus some element. We're 85% sure that this is going to be so. Kevin, have you had to deal with the whole accuracy versus precision thing, or maybe Wyatt?
I have, and so when we create a forecast using this Monte Carlo method, what we're really saying is that it's going to be on or earlier than this date, right? The latest simulations in that 85% group were on this date. There were a bunch of simulations that were earlier, right? So maybe it's going to be earlier because nobody's going to be upset if you're early, right? That's rarely a problem. So we always talk about that range being on or earlier than this date, not it's going to be delivered exactly at this time.